Okay, here we are in our second video and our last video for section 1.3, describing distribution with numbers. What does the standard deviation tell us about the spread in a set of data? So we've talked about different measures of center, and now we're going to talk about a particular measure of spread that we haven't really gone over. You've seen it before, but we will discuss it further here. When we're talking about spread, of course, you can use the range, which is from the minimum value to the maximum value in your set. But another way to measure spread is the standard deviation. And the standard deviation, literally, if I were to read this equation, is the square root of the average of the squares of the distances of each observation from the mean. So you take each observation, the distance from the mean, and you square that, you add those all up and divide it by your number of values minus 1. This particular standard deviation is called S. And standard deviation means the average distance to the mean. And that's essentially what you're doing in this formula. Okay, so I'm going to have you take a minute to get that definition as well as formula down in your notes. Things to remember about the standard deviation. Well, from the standard deviation, which is S, we can square that value and we get what's called variance. And we will refer to variance another time, but a variance is another essential measure of spread in a way. But how the numbers vary from one to another. We also, if the observations are widely spread about the mean, then the S is getting larger. So the wider the spread is, the larger your S is. And that's why your standard deviation S is a measure of spread. The sum of the deviations from the mean is 0. So if we were to just take each value and subtract it from the mean without squaring it in our formula, it would just add up to 0. So that's part of the reason why we square them. Another part of the reason why we square them, then we take the square root, is because we don't want the distance of negative values to be incorporated there. So that has to do with why we also square them. Gets rid of the negative values. S is not resistant to outliers. Outliers affect your range, your spread, and therefore they affect your measure of spread, S. So if you are looking for a measure of spread that is resistant to outliers, this is not it. If you get a circumstance in which your S is 0, that means that there is no spread for your data and all of your observations are the exact same value. So there is no spread, everything is the same value. And so you use X bar and S for whenever you have a symmetric distribution and without outliers. So not your skewed distributions, not your distributions with outliers. Those are the ones that you don't want to be using X bar and S for. Here, if you have a symmetric distribution, not skewed, no outliers, X bar and S are good measures of center and spread to be using to describe your distribution. So now using our formula, what we're going to do is we're going to calculate a standard deviation. We're going to do it by hand, and then I'm going to show you how your calculator does it for you. Because this formula is going to take you a minute, especially as the number of values increases. So the data set that we're talking about here is ones with values 1, 2, 3, 4, and 5. So there's only 5 numbers in this set. That means your number of values is 5. And I can calculate the mean really easily. I add up all of my numbers in my data set, divide it by the number of the total number of values that I have, and I get that my mean is 3. So now I have my n, I have my mean, and now I'm just going to take the sums of the differences of the mean to each value, square it, and divide it by your n minus 1. So here I've written out my s equals the square root of, take 1, subtract 3, square it, plus 2, subtract 3, square it, plus 3, subtract 3, square it, plus 4, subtract 3, square it, plus 5, subtract 3, square it. So I took each of my values in my set, subtracted the mean from them, squared each of those individually, and now I'm adding them all up. And then I've divided it by my n, which is 5, minus 1. Condensing that down a little bit more, so 1 subtract 3 is negative 2, negative 2 squared is 4. 2 subtract 3 is negative 1, negative 1 squared is 1, so on and so forth. So I end up with 4 plus 1 plus 0 plus 1 plus 4 divided by 4, or the square root of 10 fourths. And approximately that ends up being 1.58. This was relatively easy to do with a section of numbers that is small. However, as the data set values increase, the values themselves increase, or the number of values that that you have increase, calculating S is not so easy to do. So I'm going to show you how you do it in your calculator. You turn your calculator on, and in your stat menu is when you hit enter to edit a list. I have already in list 1 programmed 1, 2, 3, 4, 5, which are the values in my data set. Now I'm going to calculate one variable statistics on that. So stat menu, arrow to the right, one variable statistics, hit enter. I'm going to use list 1. That's where my values are. I see that my mean x bar is 3, so I did that right. And then I see that s of x, this third value down, is 1.58, just like I calculated by hand. So you can calculate by hand, or you can look in your calculator for SX. That's your standard deviation of x. And this is in a sample situation. We'll get to another standard deviation, which is a slightly different one later on. But here, you've got your S. That is your standard deviation here. So your calculator will do it for you and a lot faster, especially if you have a whole lot more data values. Okay, that's going to wrap up today's notes. Make sure that you've completed your box plot sheet for tomorrow. We'll discuss it, and then we'll also have another sheet to work on. Okay, see you tomorrow.